Yes, ma'am.
Yes, ma'am, you are audible. Good morning. Good morning to everyone.
Yes. Good morning. So let's welcome our today's dignitary, eminent Professor Dr. S.M. Yadav sir from SVNIT. And let's get enlightened with a brief introduction by our student, Vasu. So Vasu, over to you, please.
Am I audible, ma'am? Hello.
Yes, yes. You are audible, Vasu.
Okay. Hello. Namaste. A very agreeable morning to one and all present here. I, Vasu Shah, on behalf of the Applied Mechanics Department, LD College of Engineering, Ahmedabad, and Government Engineering College, Modasa, welcome you all for the first session of the third day of this 5 days short-term training program on disaster management and resilience and building, conducted under the aegis of Directorate of Technical Education in collaboration with Gujarat Institute of Disaster Management, Gandhinagar. It gives me immense pleasure to introduce the great personality we are having today with us, Dr. Sanjay Kumar Yadav sir, who is working as a professor in the Department of Civil Engineering at Sardar Vallabhbhai National Institute of Technology, Surat. Sir holds a master's degree in water resources engineering from a regional engineering college, which is presently known as Sardar Vallabhbhai National Institute of Technology, Surat, and holds a PhD degree in civil engineering from SVNIT, Surat. Sir has guided more than 50 dissertation studies of SVNIT and Gujarat Technological University, Ahmedabad. Sir has published the more than 40 research papers in national and international journals and authored approximately 200 conference papers. Sir has completed 2 research projects and has one ongoing research project. Sir has also completed 50 consultancy design projects like check dam design, stormwater network design, water supply network design, water conservation projects, recharging structures, and modeling of the drainage channel as a flood mitigation measure. Sir has delivered a number of expert lectures, webinars, and authored articles in magazines like Master Builder. Sir has imparted flood modeling and analysis training to more than 300 assistant professors, research scholars, and engineering students from India, as well as institutions like the Asia Institute of Technology, Thailand. Sir has received thrice OSAID funding to present his research work at River Symposium conferences held in Perth, Melbourne, and Brisbane. Sir is also recipient of the prestigious Best Paper Award by Hariom Ashram Prerit Sri Bhai Kaka Inter-University Smarak Trust Award. Sir has served as the Dean and Head of Department, apart from work as Chairman of various institutions and administrative committees. Sir is a Fellow of ISH and the Institute of Engineers, a Chartered Civil Engineer, and a member of 10 national and international societies. Now I would like to request Dr. S.M. Yadav sir to share his wonderful experience and words of wisdom with us on the concept of mega disaster of India and lesson learned, analysis of 2017 extreme precipitation and flooding of semi-arid Banas River Basin, India. Now over to you, sir.
Thank you for nice words and introduction. I'm sharing my screen. Please
Yes, sir.
let me know that whether my screen is visible. Yeah, please tell me that whether my screen is visible.
Yes, sir. Yes,
Hello.
sir.
Sir.
Yeah, and am I audible clearly?
Yes, sir.
Yes, sir. You are clearly
Yeah.
audible.
Okay. So good morning, everyone. Good morning, all the participants who are attending this disaster management and resilience building short-term training program, which is organized by Applied Mechanics Department of LD College of Engineering, then Modasa, and the Disaster Management Cell of State of Gujarat. Uh, Participants, I feel I want to congratulate you that you have joined this STTP, which is of extreme importance from climate change point of view. What's happening over the world when you are looking at this specific slide of mega disaster of India and lesson learned. Right now, at this moment, the part of United States of America, part of China, part of Pakistan, and even our own country some parts are facing disaster due to floods. And it has been found that the disasters due to floods has increased considerably in last decade. There are disasters like disaster due to drought or earthquake or cyclone. And if you talk some 20 years back, the disaster due to floods were not that significant as it is since last 2 decades. So all over the world, the problem of managing high intensity, short duration rainfall is a challenge. And in a right way, this particular short-term training program, which is arranged to understand how to manage and develop resilience or develop the cities which are resilient against such disasters. You may be knowing that Surat is one of the city which has received award of most resilient city recently. And Surat is also prone to recurrent flooding. But even after major flood of 2006, if you will visit today city, that is in 2022, and you will not believe that 90% of the city was underwater during 2006 flood, and number of people died, and damages worth 2,000 crores approximated due to flood of 2006. So that is called something as the resilient city. And because of that only, there are so many new projects are also going on in the city of Surat, like diamond boots, metro rail. We have textile industries and industries in the Hajira sectors. And even after number of floods, even after recurrent flooding in the city of Surat, the growth of Surat is considered to be one of the fastest growing city of India, or one of the fastest growing city of the world. Among fastest growing cities of the world. So that is the resilience. That is the power of resilience, building resilience of city of Surat. However, today I have chosen not the topic of city of Surat and how the disaster of 2006 is managed in this during 2006 floods. What were the measures taken? What were the lessons learned out of 2006 floods, and how the city has progressed after 2006? That topic I have not selected today, but I am going to talk about the 2017, specifically July 2017 disaster in the semi-arid Banas River Basin. We'll talk about that. See, first thing is that in title, those faculties who are from water resources, or those who studies the terms related to hydrology, find that there are contradictory terms in the title itself. One side I am talking about extreme precipitation and flooding, and other side I wrote in the title itself it is a semi-arid basin. Yeah, so you can see here I wrote it is an extreme precipitation and flooding of semi-arid. If I say that the basin is semi-arid, there is a no question of extreme precipitation and flooding if the basin is semi-arid. That's the point of discussion here, right? When we talk of disaster and managing disaster, what's happening? Because of climate change, the regions which are not receiving even few of rainfall annually are now receiving hundreds of of rainfall in 4 hours or 5 hours. Probably all those who are watching news or reading newspaper might have seen the pictures of flooding in UAE just 2 days back, wherein the due to floods, the cars were drawn into the flood water. So that is desert, and that desert has received in 4 hours more than 100 mm of rainfall, and that has resulted into flooding of UAE. So when we talk of semi-arid region, and in semi-arid region, when we say that extreme precipitation and flooding, this is becoming more and more common events, more and more common in semi-arid flooding of semi-arid region also, owing to climate change. This is happening because of climate change, but we will not go into the depth of the reasons why the climate is changing, and because of that, what is happening globally. But to explain my title, I'll say that this extreme precipitation and flooding happened in semi-arid Banas River Basin. That is the effect of climate change. This is one of the reason, right? Or impact, rather we can say impact of climate change. This is an example that how climate change impact the semi-arid Banas River Basin. I have divided my presentation in two parts. In first part, I'll be discussing about the extreme precipitation, that is the weather, how it has resulted into heavy rainfall. And in the second part, I'll be explaining you how this flooding has been modeled, what were the reasons, and what made the flooding worst. In detail, we will do the analysis of it. This specific presentation, which I'm going to share with you later on also, you can definitely get all the slides of this particular presentation, and you can share it, you can use it for your academic purpose, and wherever it is required, you can cite this particular presentation with this citation. So we'll be talking about introduction, importance of the study, theoretical background and literature, study area, and what are the data sources we have collected to do the modeling of this particular event. What were the causes of floods of 2017? Model development. We have developed two models, 1D hydrodynamic model and 1D 2D coupled hydrodynamic model, to see that how the flood has moved and what made the damage is worst. Finally, conclusion and acknowledgements. As I said, that a flood is an overflow of water that submerges land that is usually dry. Floods are most frequently occurred natural disaster in India, and India has witnessed so many deadly floods, particularly during the monsoon season that runs from July to September each year. Floods are one of the foremost reason for the loss of life and property due to its devastating effects. Flood are a natural phenomenon, but its behavior and probabilities are increasing due to human activities in floodplains. This is another reason why there is a more loss of life and property, because the people, because of population, growth of population, the people started living into the floodplains which are prone to floodings. For effective management of floods, reliable hydraulic models are required to accurately predict the level of water and discharge at different places along the river. Stages in the river and its corresponding discharges and various other parameters are dependent on the channel roughness. Hence, prediction of channel roughness also plays a major role in hydraulic modeling. With the advancement in computer technology, we can have 1D, 2D coupled and 3D modelings. Although studies on hydraulic modeling for rivers having certain limitations in India due to absence of decent quality of surveyed data, the scarcity of the observed stage and flow hydrograph and limitation of surveyed cross-section are the main reason for the restrictions of studies on the river hydrology in India. When we are talking about floods, when we are talking about managing disasters and developing a capacity building resilience or the capacity building against such type of a disaster, one of the major problem researcher faces is the lack of data availability. Because if you have a data, you can model it and using those past data, you can decide about the measures or mitigation measures for the floods, future floods. In July 2017, India witnessed a series of flooding due to excessive rainfall in the monsoon season. This July 2017 is not only received, only Gujarat received the heavy rainfall, but Assam, Rajasthan, Odisha, Madhya Pradesh, Tripura, West Bengal were flooded in many parts, which has resulted into the loss of life for hundreds of human and several animals, also caused extensive damages to infrastructure. That is in July 2017. The regions which were not flood prone earlier are also facing floods frequently. For example, the semi-arid region of Gujarat, that is northern part of Gujarat, which includes Aravalli, Banaskantha, Gandhinagar, Mehsana, Patan and Sabarkantha, was affected by severe flooding in July 2017 due to heavy rainfall. So as I said that I am going to discuss two things in this particular presentation. One, extreme precipitation. This is the second part, heavy rainfall. And because of this extreme precipitation, it has resulted into the flooding of semi-arid river basin. If apart from this excessive rainfall, sometimes the failure of man-made structures like dams, embankment, canal, etc. also cause severe flood in the surrounding region. Many cases of breach of dams, embankment and canals have been recorded in India. This interference of humans with nature for different needs results in high magnitude disasters. In view of the severe impact of floods, it is necessary to study and improve the scientific understanding regarding the phenomenon of the flood. So to do the disaster management, what we need to do, what is the prerequisite? The prerequisite is that we should understand the phenomenon of the flood. Now we'll be coming to the semi-arid river basin, for which I am going to explain you how and which way the flooding happened in case of Banas river. So Banas river is one of the major waste flowing river, having total basin area of 6,112 kilometers square, flooded in July 2017 due to unprecedented inflow. Why this unprecedented inflow was developed? The Banas river originates from Mount Abu, and Mount Abu, Disa, Banaskantha, Dantewada regions of the catchment received rainfall of 1,473 mm, 269 mm, 150 mm and 490 mm respectively within 48 hours. That is from 23/7/2017 to 24/7/2017. If you talk of 1,473 mm of rainfall, 1,473 mm, approximately 1,500 mm rainfall. If 1,500 mm rainfall falls in 48 hours, let me tell you that the annual average rainfall of Surat is 1,100 mm. Means in 4 months, the city of Surat received 1,100 mm rainfall. While look at this figure, which is of Mount Abu in the month of July 2017, that is between 23/7 and 24/7, up 1,473 mm of rainfall received only in 48 hours. Only in 48 hours. So you can understand what is the magnitude of rainfall. When I'm saying extreme precipitation, it is more than that of annual average rainfall of city of Surat, which we received during 4 months, 1,100 mm, which we received during 4 months. That has been received only within 48 hours by Mount Abu. And this particular rainfall is a record rainfall of last 100 years return period. So this much of rainfall has never fallen 100 year in the history of 100 years at Mount Abu. And this Banas river originates from the Mount Abu. So you can understand what may be the high inflow of water the Banas river have. While the annual rainfall of basin, that what I said, 921 mm. So entire basin's rainfall is 921 mm, while the part of the basin, Mount Abu, Disa, Banaskantha, Dantewada, they have received 1473 mm, 269 mm, 150 mm and 490 mm of rainfall from 23rd to 24th July 2017. Right? So that is maximum of the past 112 years. In addition to it, Mount Abu being a hilly region produced high runoff, which resulted in filling up of two dams. One is Dantewada Dam and Sipu Dam up to its full reservoir level. And that has forced the authority to release water from the dam. The basin is having such characteristic that the depth of river and carrying capacity decreases from downstream of the confluence of the river. Again, this river, Banas river, is river flowing in semi-arid region. And when the river is flowing through semi-arid region, they have less depth, right? And carrying capacity very low. So because of flat topography and low carrying capacity, the water in the downstream region has a tendency to spread laterally. So when the depth of water is less, and if huge amount of water or huge amount of discharge that flows to the river, what will happen? Because the depth is less, so water will spread on either bank up to square kilometer of areas. So this is the image contour map of upstream of the study area. You can see this is hilly region, and from this hilly region the runoff has generated, and which has, see, this is the direction of flow which has generated, and that flow has been, there were two dams. You will see here, this is Sipu river and there is a Sipu dam here. This is Banas river, which is Dantewada dam here. So there are two dams. One is Sipu dam here, another one is Dantewada dam here, and they both confluences approximately 8 kilometer downstream of Sipu dam and that of Dantewada dam. So in addition to it, Narmada main canal has been constructed perpendicular to the river flow, which has obstructed the floodwater and resulted in the increase in the inundation dam. The canal was also breached at number of locations near Thara village, which causes more damages in the downstream region. This we will see. I have pictures also. I'll show you. I've done modeling also, that how the water has moved, which has been released from the Dantewada and Sipu dam, and how it has breached the Narmada main canal, and because of that, how the damages has happened to the number of villages which are near the canal, near the left bank, near the right bank of the river. The floods have impacted lives and livelihoods, including education and public transportation, by damaging roads, highways, railway lines, airports. From the survey results, the total payable relief for agriculture, horticulture, cattle, and land damages stands to 1,653 crore. The cattle loss stood at 14,300, while 200 human lives were lost during monsoon 2017. In a heartbreaking incident, 18 members of the same family, those who may be having a habit of reading newspaper, may be knowing that 18 people of one family died in Kharera village, right? That is of the same family killed in a village in Banaskantha. 5 national highway, 156 state highways and other 550 roads under panchayats were affected due to Banas flood in 2017. So it is necessary to study the flooding behavior and development of the flood inundation maps with the effect of canal structure in inundation to select proper mitigation measures. So these are some of the pictures of the flood inundation due to Banas flood 2017. You can see here on this side that is damaged roads that has been observed. Here aerial view of the 2017 flood. You will not see where is the river. Almost all the part have the river water. This These are the houses which are damaged. Umbri village, that is in which the water has entered, that is fully flooded. This is again a Abhiana village. You can see here the water is approximately having 6 to 7 feet depth during 2017 flood. This is the damaged Narmada Canal. As I said that the Narmada Canal is constructed perpendicular to the direction of the flow of the river, and the discharge was so high that it has overtoppled this Narmada main canal, which is partly below ground and partly above ground. So this is the damage Narmada main canal because of 2017 flood. This is the rescue operation carried out by NDRF team, and you can see the picture of that. The people have been moved from villages to the safe place or shelters during July 2017 floods. So for modeling, you need some basic equation for 1D modeling and 2D modeling. So for 1D modeling, we have used the continuity equation, which is shown over here. The momentum equation, that is Saint-Laurent equation, is used for the what you can say 2D modeling. The fully dynamic model momentum equation, which will have the local and convective acceleration term, pressure term, gravity and friction force. Then again the dynamic wave, the term with pressure, diffusive wave, and the term with gravity and frictional process results into kinematic. So fully dynamic model, this model incorporates all the terms in the Saint-Laurent equation. The equation is classified as the partial differential equation. The propagation of wave takes place in the upstream and downstream direction, as well as which depend on Proud number. For the 1D model, software based on the dynamic wave equation are like Hackers, Mike11. So for 1D model, the modeling can be done into using Hackers software. The 1D modeling can be done using Mike11 software. The Mike11, when we talk of Mike11, Mike11 uses the 6-point Abbott Isonescu implicit finite difference scheme for the solution of Saint-Laurent equation for each model. The kinematic wave model, diffusive model, and dynamic wave model. The solution scheme is performed on computation grid of Q and H points. So you can see alternately H, Q, H, Q, H, Q. So the computations are done, right, of using the 6-point Abbott implicit finite scheme in Mike11 software. During the flood in river main channel, when flow depth exceeds the bank line, enters in the low lying area of the floodplain. The floodplain acts as an additional storage for the detention of flood wave. The flow in the floodplain after overflowing from the river bank is classified as a two-dimensional flow. That means whenever the discharge carrying capacity of river is exceeded, what happens? The water will start spreading over the bank of the rivers and it will follow the natural contour. So that will be the two-dimensional flow. The topography of floodplain, surface roughness, and boundary condition are the essential requirements for numerical simulation of the floodplain. The high frequency surface data characterize the floodplain topography, which can be used to decide spatial grid resolution of the model. The grid independence test to arrive optimal size of the grid to achieve better accuracy with optimum computational efforts. Uh, these are all the specifications which are required for development of 1D 2D model. The basic parameters of 1D 2D hydrodynamic model includes Manning's roughness coefficient for river and floodplain and size of the grid for 2D modeling. The Manning's roughness coefficient need to be calibrated using past data for using further in the estimation of future floods. The 1D, 2D, the boundary conditions for hydraulic modeling of the floods, whether 1D or 2D, is generally specified as a flow hydrograph at the upstream and dynamic water surface elevation at the downstream of the river. For the urban coastal flooding, tidal variation will be downstream boundary condition if it is a urban coastal flooding. The main advantage of two-dimensional hydraulic model is that the inundation extent and flood depths can be predicted with more accuracy because it accounts the topographic and geometric information. While 1D model only gives you the water surface elevation along the section, that is longitudinal section, while in case of 2D model you will get the inundation depth, that is simulated depth, which you can compare with the observed depth and calibrate and validate your model. The only primary disadvantage is that for 2D hydraulic modeling, more computational efficiency are required compared to that of 1D hydraulic model. 1D hydraulic model are comparatively simple than that of 2D hydraulic modeling. In case of 2D hydraulic modeling, depending upon the grid size, the time required to run the software, the time required to run the model is considerable, and sometimes it is in terms of hours. The use of only 1D hydrodynamic model is not suitable as it will only give you the water surface elevation. If you want the indentation depth, then you have to go for 2D hydraulic modeling. Sometimes what we do, we couple 1D and 2D hydraulic 1D and 2D models so that the discharge which is carried by or discharge which is computed or water surface elevation which is computed using that of 1D hydrodynamic model that is used for 2D modeling, from which we can find it out the inundation depth and the flow velocity for a particular flood event. The calibration of model depends upon the observed water depth, observed water surface elevation of that particular flood or the event for which we are carrying out the modeling. So once the calibration is done, calibration and validation is done, the model is ready for future events. In case of the different discharges, you can run the model and you can get what you can say, what will be the water surface elevation for various input data of rainfall. See, Banas River Basin, as I said, that it originates in Pindwara village in Siroi district of Rajasthan at an elevation of 372.5 meter above mean sea level. It meets the run of Kutch. Length is 266 kilometer. Drainage area is 8,674 kilometers square. 38% lies in Rajasthan. 62% falls in Gujarat. It is bounded by Luni Basin in north, Saraswati Basin in the south, and Aravalli Hill ranges in the east, and finally Arabian Sea in the west. When we were studying this particular basin, we have found that when the discharge was increased, when the flood that is for Banas Basin, that increases by certain magnitude, what happens that the water starts flowing into the adjoining basins. So as it is said that the Luni Basin that is in north, Saraswati Basin in the south, and Aravalli Hill ranges in the east, and finally the Arabian Sea. So when there is a flood in the Luni Basin, there are chances that the water of Luni Basin may start flowing into Banas Basin. When there is a flood in Saraswati Basin, it may happen that the water from Saraswati Basin may start flowing into Banas Basin. Similarly, when there is a floods in the Banas Basin, so they are known as overlapping basin. So when we were doing the modeling, this is for the young modelers or researchers who may be doing flood modeling. Sometimes what happens, even though they have given the boundary conditions in their DM, but they found that the water is starting overflowing that boundary. Why this happens? Because the elevation of the adjoining basin is such that the water of one basin may overflow into other basin. And this I have confirmed later on with the director of Gary that, sir, we are facing this specific problem when we are doing the modeling of Banas River Basin, and we found that the water of Banas River Basin is overflowing into the adjoining basin. So whether we are doing any mistake or the topography is such that these basins are overlapping basin, and he has confirmed as he has worked on site and he was very well aware of this North Gujarat region. He confirmed that yes, sir, these basins are overlapping basins or overflowing basins. So the average annual rainfall of basin 921. Climatic conditions of the basins are variable. Mount Abu is one of the coldest region, while the run of Kutch, that is desert, where the river confluence in the run of Kutch, so which is considered to be one of the hottest region. So this is the area map of the basin, study area and data sources. Now I want all the participants to please pay attention, because if you will understand this particular figure, then you will be able to understand what I am trying to explain you, or why I am saying that it is a mega disaster, right? The word which I have used in my title of the presentation as mega disaster, the secret of it lies in this map. See, this is the basin. This is Banas River Basin. You can see this is the hilly region. What I said that this Banas River originates from Mount Abu. This is the region of Mount Abu. You can see this is Swarupganj. This is Mount Abu. This figure. I think my pointer is visible. Somebody please reply whether you can see my red pointer moving. Hello.
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Red pointer. Can you see the red pointer is moving on screen?
Yes, sir.
Yes, sir. Yes, sir.
Yes. Okay. So this is Swarupganj. You can see this is Sirohi on the top, and this is Mount Abu. So this Mount Abu, Sirohi, Swarupganj received how much mm of rainfall? Can anybody tell me? I have explained you just few minutes back. Hello, participant, please respond. This Mount Abu during 23rd of July, 48 hours received how much mm of rainfall? Anyone?
Sir, we need to unmute them. One sec, please, sir.
Yeah, please. They can raise hand and then you can unmute them. Any participant?
Yes, sir. There is one. I will unmute him.
Anyone
Yes, sir.
raise
Mr.
hand?
KB
Mr.
Hello.
Naveen Prakash, please go ahead. Please unmute your mic and you may answer.
Reply.
Sir, 1473 mm.
Very good, very good. So I'm very happy. So this is the Mount Abu, right? And this is Sirohi. And this received 1473 mm of rainfall. Now you can see from Sirohi to Swarupganj to Abu Road, this is the Banas River. And here is the Dantiwala Dam. Okay. So this entire flow on 23rd July, 48 hours, that has rushed into Dantiwala Dam. Similarly, this tributary you see, that is Sipu River. This tributary is Sipu River, and there is a Sipu Dam somewhere over here, which has also received very heavy rainfall. So now I am coming to the left side figure. You will see this is the Banas River tributary, and this is my Dantiwala Dam. This is my Sipu River tributary, and this is my Sipu Dam. Okay, and entire basin, this part has received heavy rainfall. This also have received heavy rainfall, as well as this part is also have received heavy rainfall. And as I said, that Narmada main canal, so this line which you see, this is the Narmada main canal. And that what I said, that the Narmada main canal is crossing the Banas River perpendicular to it, right? So this is my which river? Which river? This is Narmada main canal. And this Narmada main canal is partly below ground and partly above ground. You can see here somewhere Kamalpur. This is the Kamalpur is the gauging station. This is Randhanpur, which you can see. And near the confluence of this is the Disa here, right? That is confluence of Sipu River and Banas River, which is near Disa. And this Disa was having 1.5 story water in this particular village, right? During 23rd and 24th, after 23rd and 24th of July 2017, 1.5 story water was there in this particular village, because there was heavy releases from this dam. Heavy releases is from which dam? This is Sipu Dam, and this is Dantiwala Dam. So from Sipu Dam also, because the runoff was so high that the dam were filled up to FRL. I'll show you in the next slide that what was the condition of dam, but you understand entire basin and keep this picture in your mind, so that when I will explain you in the next step how the disaster has happened, it will be very clear to you. So again, I will repeat last time, all the participants, please pay attention that this is the Banas River. This is the Mount Abu, which has received 1,473 mm of rainfall in 48 hours, which has resulted heavy inflow into the Banas River. Similarly, this is the basin, which also received heavy rainfall, which has rushed into the Sipu Dam. So this is my Banas River. This is my Sipu River. This is Banas Dam. This is Sipu Dam. Both confluence is near Disa. From here, the distance of this is approximately 10 kilometers, right? Then this is Umbri gauging station. Pink color you can see where I can measure my discharge. And there is another station, Kamalpur gauging station, which is after the Narmada main canal, where also I can measure the discharge. And this one is my Narmada main canal. So after understanding the study area, let us go to what we can say the analysis part of it, that what Sipu is a major tributary on the right bank of Banas River, and there are 6 tributaries. The Sipu also have 6 tributaries: Bataria, Sukli, Sevran, Sutket, Balram and Kari. They drain into the Sipu River. Sipu is one of the principal tributary of Banas River. That what I have already explained. Originates from Mount Abu. 30% of runoff of Mount Abu Hills meets Sipu River, while 70% of rain drains into Banas River. So entire Abu River, Mount Abu rainfall, Aravalli rainfall, you can say 30% drain into the Sipu and 70% drain into Banas River. And as I said that the Sipu and Banas both confluence 12 kilometers downstream of the Dantiwada Dam near that of the Bharat village. There are 2 major hydraulic structures, Dantiwada Dam and Sipu Dam. That what already I have explained. The Dantiwada Dam is on Banas River at a discharge at a chainage of 105 kilometers from its origin and catchment area of 2,862 kilometers square. While Sipu Dam is on Sipu River, 60 kilometers from origin, and its catchment area is 1,222 kilometers square. Why I am stressing on catchment area? Because the rainfall on this area that will directly drain into Dantiwada, and rainfall on this area, that is Sipu Dam, that will be directly drained into the Sipu Dam. There are total 4 base stations: Swarupganj, Abu Road, Sarotari, Chitrashani, that are used for inflow forecast. So next I'll show you the line diagram. From that you will get idea that how the forecasting is done. So you can see the line diagram of this particular river. You will find that origin of Banas River, Aravalli Hills. What dimension it is given? That is Kalumbari Dam. That comes to Swarupganj. From Swarupganj, Sarotari. From Sarotari, it is Balundra. From Balundra, Chitrasani. And from that, the flows comes to Dantiwada Dam. So now, what is the significance of forecast? We are attending short-term training program on disaster management. So it is very important for participants to understand that how to manage the disaster. And to manage the disaster, the very first thing which is required to understand in case of flooding is warning. Right? How much flow is received by the dam, because depending upon the inflow, the dam authority will decide about the outflow. And therefore, you will see here in the bracket it is written CWC, CWC, WRI and CWC. That means these are the sites which are managed by Central Water Commission. And at Swarupganj Dam, not only the inflow, but outflow from the Swarupganj Dam recorded and communicated to downstream. Similarly, at Sarotari, what is the gauge at what particular time recorded and communicated to Balundra. and from Balundra, it will be transferred to Datiwada. So, Datiwada Dam receives forecast from Chitrasani also, from Balundra also, from Sarotari also, and from Sarupganj dams. Many of you may be knowing Ashok Bhai Gabjar, who is the pioneer for the construction of Sardar Sarovar Dam. And those who are aware about the Narmada Dam, they may be knowing that there are series of dams on Narmada main river. So he used to tell me that, sir, during monsoon season, when there is a heavy rainfall in the Narmada Basin, all the executive engineers keep in touch with each other. And nowadays we have mobile phone. So we have numbers of all the executive engineers who are in charge of number of dams on Narmada main river. And they just keep on talking with each other. How much inflow is there? This much. So from that, they compute that how much water will be received after how many hours in Sardar Sarovar. So similarly here, the Datiwada Dam in charge knows that how much water will inflow into the Datiwada Dam after what time period, right? Because the distances are known to him. So he knows that this much of, and the dam level, what is the inflow level, or how much is dam filled, that he already knows. So accordingly, he prepare himself for operation of dam. So this is about Datiwada Dam. Again, in Sipu River, 63 kilometers of the from origin. This is the dam, Sipu Dam. You can see here there is no upstream warning station which is required to be set up so that one can know that how much water is inflowing into the Sipu Dam. When we talk of downstream of Datiwada Dam and Sipu Dam, just 12 kilometers downstream of it, both the river confluences, that is Banas River and Sipu River. And from here, it flows further, that is Umri, then Kamalpur gauging station, and then it goes to the Run of Kutch, right? Khari River. And two rivers in between it meets it, right? That is Khari River, Sukna River, Chikwara River. These are all the tributaries which are meeting on the downstream side of it. So, water received from Mount Abu, that will be stored into that of the Datiwada Dam, and another from that of the Sipu Dam. But releases from Datiwada Dam and Sipu Dam, after 13 kilometers, they have only one stretch of river, right? This is the single stretch of river, which is 30 and 10, 40, 40 and 20, 67. 67 plus 43 and 11 up to the little run of Kutch. What happened? These are all the details of the stations, Banas, Sipu, A, B, C, D, right? How much catchment area it drains, right? Aridity index, as I said, that it is a semi-arid river, semi-arid basin. So that aridity index has been computed, that is precipitation divided by evapotranspiration of that specific area. When you potentially evapotranspire, you take the work out the ratio of it, and the value of that AI is less than 0.03. It is hyper-arid. It is between 0.03 to 0.2. It is arid, and 0.2 to 0.5. It is semi-arid. Okay, this definition is given by UNESCO 1979. The study area and data collections, that monthly average climatological data for Disha IMD station has been collected, and you can see that rainfall and evapotranspiration, these are the average values of it. In maximum is July 2015.7, right, and 155. The annual average precipitation of the region is 578. This 578 and 188.6.2. That is evapotranspiration rate, which makes it a which one? Which one? This is semi-arid region. So this is the computation for why we call Banas River Basin as a semi-arid region. The Narmada main canal, as I said, that contour canal, and it is crossing the main river at particular cross section. That detail is given here, right? Then the Narmada main canal section, that is from this kilometer to this kilometer channel, the bed width is 33.7, full supply level depth is 6.5, inner slope is 2:1, bed gradient is 1 in 15,500. While the discharge carrying capacity of this Narmada main canal is 13,683. The canal siphon having a total length of 700 meter has been provided where it crosses the Banas river. Now, what is this? Right. So, as we have seen in the previous slide, yeah, somewhere here. This is my Kamalpur gauging station, and below Kamalpur or above Kamalpur, yeah, this is my Kamalpur, and this is Narmada main canal. Okay, so Kamalpur and your Narmada main canal is somewhere here flowing here. So it crosses. So wherever there is a river and canal crossing, what we provide? We provide siphon aqueduct. And this siphon aqueduct of 700 meter width has been provided. 700 meter I am saying, 700 meter width siphon aqueduct is provided where the Banas river was crossing the Narmada main canal, right? So that is the existing condition of the study area, that this 700 meter of canal siphon means if this river is like this and canal is going like this, here the canal siphon is provided which will be below the river. River will go on the top and the canal will go below it. Okay, that is canal siphon of how much meter width? It is the 700 meter width that has been provided to allow the natural drain, that is which drain? That is Banas river water to flow without any obstruction. So, this is the picture of the river. You can see the Dantewada Dam, view of the river from the Dantewada, downstream of the Dantewada Dam. You will see that it's a rocky almost, and if you look at this particular grass, if you look at the grass on the side and the depth of the river, you will find that the river depth is very less. Here on this picture also you see, this is the picture here, and this is the bed of the river. This will also help in deciding the Manning's roughness value N for computation of the discharge. At the same time, this will also help us to understand if the depth is less, the river carrying capacity is less, if there are heavy releases from the dam, what will happen, right? So this is again another picture. You can see here almost the bank and depth of river is same. This is my student, he's Nikunj Mangukia, who has done 1D 2D modeling for this particular study area, and he has not only visited this particular location, that is Dantewada Dam and Sipu Dam, but he walked in the villages which were drawn under the flood of July 2017. He visited the people who lost their loved ones. He visited people who lost their everything in the July 2017 floods. You can see here the bed of the river near Mota Jampur village. The depth of the river again you can see it's a very less. Similarly here you cannot find anything like river. Almost all the sand you can that is after Kamalpur gauging station, that is Ambian village, means almost the bed of the river and the bank of the river, they are at the same level. We have collected lot of data. The data sources were the Central Water Commission, Disa Irrigation Circle, Sardar Narmada Nigam Limited, topographical data that we have collected for river cross sections, alignment, configuration of hydraulic structure, bathymetry of the floodplain, land use, land cover, river alignment and cross sections that we have extracted from SRTM DEM of United States of Geological Survey for the year 2014. The Basin map and river alignment have been validated based on the river basin map obtained from CWC. The bathymetry of floodplain and landage land cover data, the contour of the floodplain has been generated from SRTM DM. The land use and land cover have been identified from Google Earth and Landsat 8 satellite imageries. The configuration of hydraulic structures that is Datiwada Dam, Sipu Dam, and Sardar Sarovar Narmada Nigam Limited. That is Narmada Main Canal. That data has been collected and that has been incorporated into the model. The hydrology and hydraulic data. There is a table which shows us that which data is collected from where. The flow hydrograph, that is of Dantewada Dam, means how much water is released at what time. That has been collected from Dantewada Dam Authority. Flow hydrograph of Sipu Dam, that is Sipu Dam Authority. Stage and flow hydrograph at Kamalpur, that is Central Water Commission. Stage and flow hydrograph at Umri, that is river gauging section of Palanpur. Flow hydrograph of Narmada Main Canal, that is from SSNL. And actual flood inundation depth walking along the villages of the flood affected area collected through questionnaires. So when I am presenting this work, sometimes the participant may be feeling how good the work is, or the work is carried out very simple and very easy to understand. But to carry out this work, right, it required this much of data. This is the only part of data collection. After data collection, you have to go for modeling of it. So this entire presentation which I am presenting here, this took around 1 year to prepare this particular presentation, right, to carry out this particular analysis, right? So Mike 11 uses which numerical scheme to solve Saint-Venant equation? This is the question to the participant. Let me see that whether the participant are awake or are paying attention or not. So ma'am, you can unmute. Any one of them have raised hand and reply, because I can't see them over here.
Yes, Mr. Mohit Kumar, please go ahead. Mohit Kumar? Okay. Participants, sir has posed a question. Please reply. You may unmute your mic. Your mic are now able. Everyone.
Anyone? I have explained you know, Mike 11 uses which numerical scheme to solve Saint-Venant equation? No answer, ma'am?
Yes, sir. 1 second. Let us give opportunity.
6-point method, sir.
Yes, participants.
Okay, I'm showing you the answer. Mike 11 uses the 6-point Abbott INOSQ implicit finite difference scheme for the solution of Saint-Venant equation for each model. So be attentive, because I am going to ask you the next question after 10 or 15 minutes. So those who are attending with concentration, right, with paying attention, probably will be able to answer this question. So methodology of development of 1D and 2D hydrodynamic model, we have done it using Mike Hydro River software, wherein the Manning's roughness value has been taken SRTM DM. Manning's value roughness value is considered from the photographs which we have seen and the past flood. SRTM DM we have accepted 2-dimensional floodplain model using Mike 21 software that has been developed. Then finally 1D 2D models have been coupled to find out flood inundation using Mike flood software. So this is the complete methodology, flowchart depending methodology of the work, wherein you can see it is in 2 parts, 3 parts rather. One, identifying the causes of 2017 Banas river flood. Based on that, the data has been collected. This data which has been collected, that has been used for the development of 1D hydrodynamic model. When we say 1D hydrodynamic model, the data required to develop 1D hydrodynamic models are shown over here, and using that you can finally work out the water surface elevation for various discharges for a river section which you consider for 1D hydrodynamic model. This 1D hydrodynamic model is again the output of this is used, as you can see here. This is the arrow which is the outcome of 1D hydrodynamic model for 2D hydrodynamic model. The 2D hydrodynamic model again that has been done for three cases. Number one, bathymetry mesh data, roughness parameter and HD parameters without canal. Number one, where we have not considered the canal. In case 2, we have considered the canal, and in case 3, we have considered the canal or bridge canal. When the canal is breached and then how the water is moved, that has been considered in developing the 2D hydrodynamic model. So the output of 1D hydrodynamic model is used again into the 2D hydrodynamic model, Mike flood. Using that, what we did, the simulation of 1D 2D couple hydrodynamic model is done, and the comparison of simulated and observed maximum water level in floodplain and identifying effect of canal on flood inundation. So flood inundation depth, role of canal, that also been identified carrying out this specific study, right? So how the heavy rainfall occurred? So the reason for that extreme rainfall was there were 14 low pressure system active at that time in Indian subcontinent, and these are the record of these 14 low pressure system which were active in this region during the July 2017. You will find that the depression 2, well marked low pressure 1, low pressure 3, and total 6 number of system they were acting over this Banas basin, which has resulted into heavy rainfall. I'm not reading all this, that how the heavy rainfall has occurred on this particular area, but already I have explained you that the rainfall was in excess of the rainfall, which is the annual average rainfall of the area. Here you can see the table, normal rainfall in July, specifically of DISA, 226.7 mm, while in July rainfall in July 2017 it was how much? 950 mm. So all time highest record rainfall in July is 965 in 2015. So almost you will see all the peakers, they are very nearer to or very close to the highest rainfall of that particular region, which has resulted into the flooding. This is the picture we will see here. There were two systems active at the time. Why there was heavy rainfall in July 2017? One system was moving from this side to this side, and another system which has been developed over here, that was also moving from this side to this side. Those people, if any participant is attending this this particular presentation and he is from this specific area, that is North Gujarat, in July 2017, right? He might be knowing that what was the extent of rain fallen over this region. Not only that, there was a rumor in Machu that Morbi village, that is Morbi town, that the a dam may break at any time, because the dam breached in 1979 due to heavy rainfall, and throughout the 7 days the heavy rainfall continued over this area, and this place was isolated. North Gujarat was isolated from the rest of the part of the country, and the people were not able to understand what is happening, and there was a rumor also that the dam may breach at any point of time. However, the government was continuously helping the people, rescuing the people also, and passing on the messages about the heavy rainfall which is occurring over this particular region. So this topographical as features that already I have explained you. Yeah, this is the very important one. And to understand it, how this has happened, how the disasters happened, that you can understand clearly from this. This is flow hydrograph and dam water level at Dantiwala Dam. And what is the date? 23rd to 27th July, right? This is what was the situation of Dantiwala Dam. As I say, because of heavy rainfall which is started on 23/7/2017, right? You see here, this is 23/2017 00 level. This blue line shows inflow. This pink line, not pink, orange line shows the outflow. This is the dam level and this is rule level. You understand what is the meaning of dam level and what is the meaning of rule level? Rule level is the level up to which the water can be stored for a specific month, and dam level is the level beyond which probably you maybe the top level of the dam, right? That is FRL here, it is 184.1 meter, highest level that up to which the if the water exceed this level, it may breach. Right now you see here that on 23/7/2017, right, blue line, you see, look at the blue line, right? There was a slow inflow, right? And suddenly on 24/7 midnight, the flow right from few thousand cusack to gone into 250,000 cusack, right? And this is the rule level, means you cannot store water above this particular line in a dam, right? Then after reaching this, it is the flow still continued. You can see that the flow is not discontinued. It has still continued till 26, but receding. This was rising limb. This was falling limb. While if you will see the pink line up to 24th midnight, no releases were there from the dam. And suddenly on 24 midnight, as they saw that the huge inflow is coming up to like 50,000 into the dam, what they have done? They have started releasing water right from 0 cusack to nearly 225,000 cusack water in only in few hours. You can see here, this is only few hours, right? This is here 24/7/2017 midnight to that of the morning, right? That much water has been released from which dam? This is Datiwada dam. See this line, dam level, you can see here that is up. This is the dam level and the FRL is 184.1 meter. The 184.1 meter is full reservoir level. Hence, they are not left with in any other option than to release the water at such a high rate, right? Releasing water from a dam within few hours, which is equivalent to 250,000. This is the situation of which dam? Datiwada dam. Now see the next. This is which dam? Sipu dam. And in Sipu dam also, if you will see inflow. So inflow 24/4. This is the rule level for Sipu dam. And that is also approximately 225,000. And this inflow is cross 225,000. And the Sipu dam also started releasing heavy discharges up to midnight. This all happened in midnight of 24 and 25, and the release is 250,000. So 250,000 from Sipu and 250,000 approximately from whom? From Datiwada. Now you look at this confluence. What will happen to the people of downstream side? That is my point when I'm trying to explain you this. Where is the line diagram? Let me show. This is the line diagram. Now you imagine 250,000 is released from here. 250,000 is released from here. So when it conflues, how much here? Hello, everyone. Anyone please unmute and tell. 250,000 is released from here. 250,000 is released from here. So at this point, how much water will accumulate? Anyone? 5 lakh cusack. And when there is a 5 lakh cusack of water, and that too when? Midnight of 24th. People who were sleeping alongside of the bank, it is said that the water first having a depth of 30 centimeter. When it entered in their house, it was 13 centimeter. And within 1 hour, the water level in the house was up to chest level within 1 hour. You can imagine the situation of the people. Can you imagine that if you are sleeping in a house and suddenly in your house 30 centimeter depth of water, and after that it becomes approximately equivalent to 1.4 meter or 1.5 meter, what will be your condition? So people were sleeping that time, and this water which has been released from both the dam rushed into all the areas which are adjoining to this that is beyond the confluence, which is 5 lakh cubic, while the carrying capacity of river was hardly few thousand cubic. While we are releasing approximately 2,50,000 cubic of water, which has inundated the entire area. Right. So this is 1D model. I'll not show you the steps, how the model has been developed. I'll just show this is the Sipu Dam, this is Dantiwada Dam, this is Umri Gauging Station, Kamalpur, all the cross sections we have taken, and that we have given into the Mic 11 software, and we have find it out what is the discharge and what will be the water level at various locations. Right. So you can see here various changes and various changes. What are the nearby villages? This is the village, Kharia village, where the 18 people of one family died, which is very close to that of the canal. And as I said, within no time, it was a kacha house, as you see in the villages, and the entire house got submerged into water. So where the people will go, they are not able to escape from it, and 18 people died in this Kharia village. So these are the cross sections of it. The inflow flow diagram were given, Dantiwada, Sipu Dam and Kamalpur water level gauging stations, and based on that hydrodynamic parameters were worked out, and using that that has been computed, the discharge has been computed, and all statistical computations were done to validate and calibrate the Manning's value of an that discharge is used for development of Mic 2D model. This Mic 21 model, these are the area which we have considered for the modeling purpose, and following the steps, model steps, giving the land use land cover, Manning's coefficients. Model has been developed in Mic 21 and it has been run in the Mic 21. First, without considering the canal. Second, considering the canal. And third, considering the breached canal. And the results of this developed model, aerodynamic models, I'll like to show you here that how the water has moved from this one. These are for the calibration purpose. Calibration and validation purpose, as I said, this Nikunj has visited the villages. This is the questionnaire form, and he has collected what is the actual water depth, right? Which can be used for the calibration and validation of the model. So these are all 1D hydrodynamic model results. What will be the water surface at different time? This is 25/7/2017 time time series water level, and this is this will be water level. This is time series of discharge at 25/7. What may be the discharge? Likewise, this is 25/7 time series of depth of water and time series of flood. What is that? That is D. These are the output of 1D model. This is the again diagram which shows the how water level has moved. This is the condition of one particular cross section, that the water level at given time step, maximum water level at this cross section. So you can see that the at this time the depth of water at this is approximately 125.75 and this is 128 approximately. So each section is over flooding by approximately 3 meter of the depth of water. With to compute particular value of n, making the RMSE low and selecting the final value of n, the exercise has been carried out, which has been shown for 2015 flood, and the 1D hydrodynamic model water level has been worked out with 2017 observed water level and the simulated water level using 1D model. This is again the observed water level and simulated water level for 2015 flood at Umri gauging station. The same has been used for modeling 2017 flood, right? So these are the cross section changes, left bank, right bank, and water level. And from that, we can able to find it out that from which cross section the water might have overflown. So this is these are the sections from where in 1D model you can say that for example at 82,619 the water which is overflown from left right bank was having height of 4.3 meter, while on left bank it is of 6 meter. 6 meter height of water has been overflown from a left bank. So these particular changes that we have marked on the Google map, and which village will have how much depth, that we can able to find it out from this, right? This is Disa, Akol Moti, then Aranpur, and these are the cross section 82619. So if you will see here 82619, so 82619 4.3 and 6.0, so 6.0. So this village probably have 6 meter of depth of water because it is close to this particular cross section. So you can exactly find out that what may be the depth of water, right? When the releases has been made into this particular river, right? So if it is the 6 meter, you can understand the kacha houses in the village hardly have a height of 3 or 3.5 meter, and if the water depth is 6 meter, almost all the houses in this village may be submerged. So similarly, you can work out the depth of water at all these places, and you can able to tell that what may be the depth of water at various places. So this is another example. Another cross sections are given, and nearby village Umri, Deliathara, which is almost on the bank of the river. What may be the depth of water be observed? This is the Narmada main canal 1976017895, and this is the Kharia village, right? So what has happened here exactly in case of Narmada main canal? Okay, I'll explain you in the next part. Then this is again the critical sections we have drawn, that where the depth of water is more than 5 meter, 3.3, 1.67 meter, from which section the water has overflown, that has been marked for entire reach using 1D model, right? Yeah, and these are the villages, for which villages what may be the height of the what will be the depth of the water when 1D modeling is to be carried out, that you can able to find it out using that this in this, but this is not different from this. This is tabular form, and this one is the villages form, right? Because you know the changes. So from changes, the changes are known to you. So from changes you can find it out what will be the depth of water in these villages, and you can go and verify it, right, by personal survey. That what we did for this specific region, right? So now when we talk of 1D 2D coupled model, that how the water has spread over the entire area. So you can see here, this is the main river and this is the result window, and 1D 2D hydrodynamic coupled model, right? One by one we will see. Now you look at the figure A, and A is without Narmada main canal. When there is a less discharge, the discharge of 24/7 2070 midnight, that is 12 o'clock, right? The spread of water was only this much. This is without Narmada main canal. Then B with Narmada main canal. So here was the Narmada, sorry, B is here. Here is the Narmada main canal, but main canal has not breached. So you can see the water is spread on this side, water is also spread on this side, right? But the sprayed area with Narmada main canal is more than the sprayed area without Narmada main canal, right? At the same time, when it is breached, when canal is breached, water has overtoppled. You can see this is the portion which is downstream side of the main canal. This is also downstream side of the main canal that has also been inundated. While here there is no water. You can see here there is no water when canal is not breached. But when canal is breached, you will see that the downstream part of it is also affected. Now slowly, because 24/7 2017, that was the starting time midnight of releases, right? So this is the just starting when the releases are started from Sipu Dam and Datiwada Dam. Over the time, you can see here, now it is 4 p.m. 24/7 4 p.m. And A is without Narmada main canal, how the water has spread. B is with Narmada canal. It is not breached. So not breached, so no water. You can see here, there is no water here. If there is no canal, the water have passed like this. If there is no canal, water have passed like this. If there is a canal, but the canal is strong enough, which has hold the water, then what would have happened? The inundated area on the right bank may be more. See, Kharia is here. Just look at here. This is the village in which 18 people died. We'll come to that. This is 24/7, 4 p.m. This is with Narmada main canal, but canal is not breached. And this picture you will see, this is the canal and the canal is breached here, right? So you can see here, no water here, while here the entire downstream area also got flooded, right? So main canal, without main canal, water have passed like this. With main canal, the main canal obstructed the water, and the depth, this portion you see, this yellow and red portion, that is the excess depth which has resulted for the inundation of these villages. Okay, here also there are villages. It is not that villages are not there, right? So till the canal is not breached, what would have happened? The water level have gone high into these villages also, right? And when it is breached, then the water level would have that have affected the downstream side of the villages. So this is 24/7 2017 4 p.m. Then next 24/7 night 8 o'clock. So 8 o'clock you can see the releases were very high. So this area again not breached. So what has happened? The water has spread from here to Runi and Kharia. That Kharia is now underwater. If you will see here, there the Kharia was not underwater. Runi and Kharia both were not underwater, right? On a 4 p.m. But on 8 p.m. they are underwater, right? And if canal has been breached, what would have happened? Runi and Kharia would have not been affected. But the water was there in Runi and Kharia. That means this particular simulation is correct, right? So what the canal might have breached, from this we can also able to conclude that what may be the time when canal might have breached. So it may be 24/7 2017 after 8 p.m. Why? Because the Kharia was inundated and Runi village was also inundated, right? The Nikunj was saying this is the main river, right? And from main river, this particular area is around 10 kilometers away from the on the right bank. So administrative authority have issued warning that please you move to the safe place, right? From bank up to 10 kilometers. The people were not ready to believe. Why? Because never the river water has entered into their villages in past 100 years, right? The authority has issued the warning that the people who are adjoining to these areas, right, up to 10 kilometers, leave the place, leave the villages and move to the safe place. They have not. The reason, nobody was ready to believe that water will reach up to 10 kilometers. But that has happened because of what you can say, Narmada main canal, right? As it is not breached. But once it is breached, you can see here, you cannot see any water in Runi or Khalia, right? So that is simulated one 24/7 2017 8 o'clock, right? Then again 25/17 midnight. This is, you can see, without, this is without Narmada main canal. This is with canal but not breached, so it is again spread to a longer distance. And When it is breached, the water, the downstream part here, the downstream part was less submerged, but when it is breached, the more part has been brought under the submergence, brought under the water. So that is the C part, that is 25:07:00 hours. Then 25:07 early morning, 4 hours. Situation become worst. You can see that was a high, showing the highest spread. This is Kharia, Runi, and maybe up to kilometers of area. Either side of this is inundated, right? This is again 25:07, 8 o'clock morning, right? This is 25:07 afternoon, in evening 4 p.m., night 8 o'clock. This, and again 26:07 early morning, right? So how the flood water retained into this particular area and when it started receding. So after 26/7/2017, slowly the water started receding, right? So the depth which has been observed at various villages, simulated water depth, simulated with Narmada, without Narmada, and actual water depth, right? That also we have compared you doing the modeling, that what may be the depth of water at various villages. These are the number of villages with the bank, with main canal, with Narmada, without main canal, with main canal, simulated depth, with bridge main canal, and the observed depth into the village from the questionnaire survey that has been resulted into. So villages which are not affected by the Narmada main canal, right? That affected, sorry, not affected by the Narmada main canal, that has been shown over here. These are the actual villages where what was the actual depth of water and how it is increased. For example, Umri village. So with the time 24th no water and 25th midnight to this one, it has reached to 1.2 meter depth of water. So that analysis also been carried out, that in individual villages how the water depth might have increased, right, for all the villages. That has been computed here and shown over here also. This is the table which shows the depth of water in the various parts. So the villages which are identified clearly, as I said, that these villages which have more depth, these Kharia, Runi, Ranakpur, Mota Jampur, right? These are the villages as an outcome of our analysis. We can say they are more affected because of the Narmada main canal. If Narmada main canal was not there, probably the depth of water may be less in this particular region. And that has been shown over here, right, at various villages, what will be the depth of the water, right? See, it is said that the siphon, which was, this is again all detailed analysis of various villages that have been shown over here, actual depth, yeah. And the one important thing which we have come across is that when this canal siphon was the construction of which was going on, the village people used to say that the 700 meter width of the canal siphon is much less. It is required to be constructed more than that of double width. They were saying that at least you provide 2 kilometer of width of the canal siphon, right? But maybe because of economical consideration or what, that has not been executed, and that has result. And after 2017 flood, it has been felt that this siphon, which is required, the carrying capacity of that siphon is required to be increased. And now on the right hand side, on this part, they have constructed additional cross drainage work on Narmada main canal, right? So from here to up to 10 kilometers, you will find that now, means today, we have number of additional cross drainage works that has been constructed on this particular Narmada main canal, so that in future, if such type of a flood comes, they will get not only 700 meter width of the canal siphon, but the additional cross drainage work that will help to pass the flood water safely without breaching the Narmada main canal, right? So that was all about what you can say the discussion which I am showing. As I said, there were concluding remarks for this specific mega disaster. Number one, that is low pressure development, one from Arabian Sea, another from the Bay of Bengal, which has resulted into heavy extreme precipitation, which exceeded 112 years of rainfall, which flooded the entire study region. The second one is, the conclusion is that the inflow was so high that dam authority has been forced to release the water. You can see that such a short period, if you will release 250,000 of water, what will happen to the downstream area of the region, which have the where the river is having hardly carrying capacity of few thousand. Listen me carefully. I am saying the carrying capacity of river is only few thousand, while the discharge released was 250,000. 250,000 cusack. So what will happen? It will inundate either bank of the river up to kilometers of length. This is the another one, that is the releases from Sipu Dam. This is also one of the releases. You can see the short duration the releases are made, and which is also up to extent of 250,000, which add up to 5 lakh, and that has resulted into devastating floods on the downstream side of the that downstream side of the Dantewada and Sipu Dam near the Disha. Right. So I hope that I have made you understand that how the floods happens, how it moves, how it bridges, what is the role of hydraulic structures, right, which come across the way of water, and how it obstructs. After obstruction, if bridging is done, how after bridging the downstream part of the what we can say portion be affected. So thank you very much. I think I have taken 5 minutes more, 10 minutes more. I have been given 1 hour 30 minutes, right? Hope you have followed this and may have some question or query. You may ask me for the same.
So now the session is open for query or questions. The participants, you may ask questions if you have. Any participant?
Yes, sir.
Yes.
You explained the entire for flood analysis, right?
Yes.
Yes, Deepa ma'am, you
No.
are not clearly audible, please.
No, I can
Ma'am?
hear her. I can hear her.
हाँ.
Yeah, please go
Okay,
ahead.
okay,
हाँ.
okay,
तो
okay.
सर यही सपोज हमको ड्रॉट एनालिसिस करना होता, तो ड्रॉट एनालिसिस में भी हम प्रेसिपिटेशन देखते हैं कि 50 साल में कितना प्रेसिपिटेशन हुआ, एंड देन वी सी द ग्राउंड वाटर व्हाट इज द, तो सर उसमें कौन से हम सॉफ्टवेयर यूज कर सकते हैं, इफ यू कैन हेल्प इन दैट ड्रॉट एनालिसिस.
For drought, SPI index is used. There is
SPI.
one paper of mine on drought
Okay.
analysis also. You just share your email ID with me. You can
Okay.
write down my email ID, SMY
SMY
@ CED, Civil Engineering Department, CED
CED
dot
department
SVNIT
dot
SVNIT
SVNIT
dot AC dot in.
dot AC dot in. So you're working with SVNIT?
Yeah, ma'am. I'm working with SVNIT.
Yeah, so you're professor there, sir. Okay, very
Yeah,
nice.
ma'am.
So SMY @
CED dot SVNIT dot AC dot in.
Yeah. Thanks, sir. Yeah. I'll get in touch with you. Thank you, sir. Very nice. It was very nicely
Thank you,
explained the
thank you,
flood
thank you.
analysis. Yeah.
Thank you.
Any other question?
Sir, just
Sir,
like
I
the
have one question.
yes.
Yes.
Somebody is asking,
Yes,
ma'am.
sir.
Yes, please go ahead.
Yes, sir.
Yes, sir. Just like you have done the hydrodynamic modeling for the Banas River. Similarly, as a part of mitigative measurement, whether any study of any other river has been done considering the hydrodynamic modeling?
Yeah, there are many studies which are going on worldwide, and like I am an expert for Uttar Pradesh government, and in case of Uttar Pradesh government, all the rivers which are centrally flowing, that which are flowing from the central part of Uttar Pradesh, have very less slope. They are almost having 11 centimeter in 1 kilometer. So, and these are the rivers which carries huge discharge. Up till now, before 10 years back, as a flood mitigation measure, they used to construct levees across the bank or on either side of the bank. But since the Yogi government has taken up, instead of constructing levees, they are advocating dredge channel. So wherever there is a flooding, a river stretch is identified, and for that river stretch, modeling is carried out, and carrying out that modeling, the length and width of dredge channel has been decided. And based on that, the dredge channel is executed in number of central Indian rivers to save the people from floods. So likewise, for almost for all basins, like Bhima Basin, if you will write Bhima Basin, so for Bhima Basin, you have real time water level monitoring or flood monitoring system, that even a participant can see what is the level of water in number of dams in Bhima Basin, and how they are operating. So that has been also developed by government of India. Apart from Bhima Basin, I think for Damodar Basin also, they have developed this real-time flood monitoring system. So a lot of work is going on as far as the monitoring and managing of floods are concerned in India as well as globally. Palak J. Shukla has raised it.
Yes.
Sir,
Yes,
just
Palak
you
ma'am.
have hello. Just you have says that the very large amount of the water released from the dam. So if we observe the hydrograph of the Dantewada dam, it indicates that the very large amount of the water is released in few hours. While as compared to if we see the Shipu Dam river flow hydrograph, it indicates some release of the water step by step. So is there any comparison between these two, sir? Is it in fact some
No,
difference?
in fact, that is the scale difference. Otherwise, you will find that both the graphs 24/7 midnight to 25 morning, almost they have released 250,000 from both the dams. The time period is almost same, Palak ma'am. That scale of graph, because of scale of graph, it looks like that.
Okay, sir. Sir, another question is that sir, there is the inflow of the water in blue lines. It is indicate that in both the dam inflow is there, but they have not released the water.
No, not. It was not like that. As I said, 1,475 mm of rainfall has been fallen in 48 hours. So you can imagine that how much amount of water inflow into both the dams within a short time period. So that this is the global problem. What is happening now is we have short duration intense rainfall, and because of short duration intense rainfall, the reservoirs are receiving large amount of inflow in a short time period of 8 to 10 hours. And during that time, if dam is full, then dam authority has no other way than release the water without worrying for what will happen on the downstream side. So this is not only the problem of India, but it is the problem of all the dams of the world. So the initial condition means the condition when there is a high inflow into the reservoir, whether the dam water level is such that it absorbs the inflow. If it is not able to absorb the inflow, then they have to release it. And when they release it, more than that of the carrying capacity of the river, it results into flooding of the downstream areas.
Okay, sir. Thank you very much.
Sir,
Any more questions?
yes, I have, sir, one from my side. Hello, sir.
Yeah, please, I can hear you.
Sir, what can be the remedial measures system can take from this experience?
Yeah, ma'am.
Or
That's
what are already done?
That's what I said, that one of the measure which government of Gujarat has initiated, that the committee has visited these Narmada main canal and affected areas, and they have redesigned the passage of water which is to be given if such flooding occurs in future. And therefore I said that it additional structures, right, which pass the flood water below the canal, that has been constructed. So the entire stretch on the right hand side of the Narmada main canal, I think up to the chainage of 10 to 15 kilometers, they have constructed additional drainage below the canal, so that if such situation arises in future, that can pass the water safely.
And sir, just a passing thought, we are creating big lakes in villages itself, 2, 3. Does it amount to any remedial measure?
Yes,
Will it have any effect?
Yes, the storage, if we have storage structures on the downstream side, then definitely they will be going to help, right, to prevent such disaster. If you talk of these storage reservoirs, Mumbai and Navi Mumbai is the example of it. Mumbai get flooded every after extreme rainfall, while Navi Mumbai get never flooded because of the same amount of rainfall which is following in Mumbai as well as on Navi Mumbai. The reason is that in case of Navi Mumbai, they have planned these storage reservoirs. Wherever there is excess amount of water, they store it into these reservoirs. And when there is a high flood into the sea, at the same time heavy rainfall, the water is stored in such storage ponds. And after the high tide level passes, they open the gate and they release the water safely into the sea. So this type of what we can say remedial measures are also helpful in relieving the pressure of floods.
That's wonderful to know from. Thank you very much, sir.
Thank you.
Thank you.
Sir, one question from my side, sir.
Yeah, please, ma'am. Please, ma'am.
Sir, every year such deadly flood hits northeastern India like Assam, and millions of people get badly affected by that. We know that. So as you have done extensive study using modeling and collecting the data in such extent, so which kind of study over there is needed to reduce, at least to reduce the hazardous effect of flood? Because it is repeating every year. I think from childhood, we got to know that, okay, some people are badly affected, millions of lives and millions of things are flooded. So which kind of plan should be there and should be taken the people over there?
So for Assam, crores of rupees has been spent to protect the people of Assam from recurrent heavy flooding. One or other measures they are every time taking care of. But what is happening that because of climate change, the measures which they took and the magnitude of flood that occur, that keeps on increasing every time. So it is not possible up till date to 100% protect the people of Assam. However, continuous measures over a period of not less than 30 to 40 years has been taken to protect the people of the Assam. But the root cause of this is climate change. And as we know, the intense rainfall is due to warmer air. It is said that the warmer air stores 7% more moisture than that of the normal air. And this is the reason because of which the extreme precipitation events are increasing globally. So till we don't find solution to cope up with climate change or to reduce the impact of this, probably at least for next 15, 10, 15, 20 years, we'll be facing this problem. What at the global level people are trying to do is that they are trying to increase the forecasting period. Like this time, the entire Assam was inundated, but our IMD has already forecasted that there will be heavy rainfall in this region for these many days. That will save people going out and taking precautionary measures, or even the administration is taking care to move the people of low-lying areas, because we have this warning in advance, and because of that, at least the loss of life, loss of cattle, that we can save because of such events. But it's a global problem. What I mean to say is that it's a global problem, and the solution, if I will talk of Kentucky, that is of United States of America, where 110 people died, while here I have shown you the magnitude which we have released was 2,50,000 plus 2,50,000, 5 lakh cusack. There the magnitude was only 17,000 cusack. 17,000 cusack, and 17,000 cusack flood resulted into death of more than 100 people in Kentucky in USA. So you can compare, right, that what may be the form of floods, right? So overall you will see that lots of efforts are required if you wanted to protect people from such extreme events.
Yes. So I think there are no queries from participants now. So everyone got satisfied happily. So let us conclude the session. And I am thankful from bottom of my heart for you, sir, for sparing your valuable time and imparting very effectively scientific understanding of flood. I must say, sir, your extensive, insightful study of cause and hazards of Banas flood of 2017, I think it imparted a deep sense of responsibility to us as civil engineers to at least learn about cause and mitigation of flood hazards. Such a depth of collection of data and analysis by you, sir. And at some point, we got totally dwelled in your presentation. At some points, I should say the results of flood hazards were so heart-wrenching that within 30 seconds, flood water can affect people in the house. So, yes, sir. So thank you very much, sir, for your presentation and your esteemed speech. Thank you very much, sir. And now our student Vasu will over the session. Vasu, please.
Hello, I am audible. Wonderful session, sir. Thank you very much, sir. This was such an informative and useful session for us. This would have surely benefited all the participants in enhancing their knowledge. So thank you, sir, once again.
So thank you very much. Thank you, organizers, sir. and all the participants. I welcome any suggestion. I welcome any sort of collaborative work. As we have done it for Banas Basin, not necessary it can be of basin level. Even for your small society, you can try to find it out some sort of flood inundation depth problem, and we can have a solution for it. So it is that much open and that much analysis we can do for right from a smaller scale of society to basin scale. So anyone at any point of time feel interested in carrying out this type of analysis, they are welcome. So I thank organizers for giving me opportunity to present my work. Thank you very much. I am leading the meeting.
Thank you, sir.
Oh, pleasure, sir.
The next session will
Hold
be at
on.